So let's go ahead and talk about that problem of the day. Be sure to answer the questions I ask out loud. Think about how your work is the same or different from what we talk about together. Okay, whose work did you agree with here? Jasmine's or James? Go ahead and say it out loud. Yes, Jasmine has the correct work for this problem. Okay, so what mistakes do you notice that James made? Say it out loud. Sure, there's a couple of things that you might have pointed out. And the first one is that he didn't fully represent the problem. Yeah. What part of the problem was he missing in his representation? Say it out loud. Yeah, he didn't include this 500 milliliters of punch that was added. And then, so how does that impact how we solve the problem? Say it out loud. Yeah, we can see down here where he's solving, he only subtracted the 1,299 milliliters. He didn't go ahead and add the extra 500 that got added back into the punch because I think he probably forgot about it, right? Because it wasn't shown as part of his representation. Okay, so now look over here at Jasmine's representation. How is her representation different? Say it out loud. Right. So in hers, she represented all parts, right? So I'm going to add that to our visual anchor. All parts of the problem are shown in this representation. Great. Okay. And again, just to remind you, you know this, there's a lot of ways you could represent. You don't have to do it all in one number sentence like she did. But the key is that you do have to make sure that when you represent, that you're representing all the parts from the story, everything that happened in the story that we need to be able to solve. Okay, so what should we be asking ourselves so that we don't make the same mistake that James did? Say it out loud. Yeah, I think it's probably just as simple as, did I represent all parts of the problem? That's something we should be keeping in mind today. Okay, so that's one mistake. What other mistake did James make? Say it out loud. Yeah, it's right here, right? When he was trying to convert 6/10 of a liter into milliliters, he drew a tape diagram, but he broke the whole into 6 parts instead of 10 parts. So I'm going to note that here. Broke whole into 6 parts, not 10 parts like he needed to. Great, so we got that captured. Yeah. And why do you think that he might have made that mistake? Say it out loud. Sure, he must have thought that where he had the 6/10 here, right, that would mean 1/6 instead of 6/10. Now, how is Jasmine's work different over here? Explain your thinking out loud. Right. She broke the whole of her tape diagram into 10 equal parts because she was working with tenths. And then she shaded 6 of them, right, because she had 6/10 of a liter. So she was able to find that 6/10 of a liter equals 600 milliliters. So let's add that. So she broke the whole into 10 parts and shaded 6 because she had 6/10. That makes sense. Great. Okay, so what can we be thinking about so that we can learn from James' mistake and not make it ourselves? Go ahead and explain your thinking out loud here. Yeah, when we're converting tenths of a unit, we have to break our whole into 10 equal parts. So read this with me. If I am converting tenths of a unit, did I break my whole into 10 equal parts? Jasmine did, James did not. All right, keep these things in mind today as you dive into your practice problems.